Hello all. Today's video is about a novel way to escape the Earth's gravity. I made an earlier video about hydrogen airships, which has some related points, but today we're talking about using the awesome buoyancy of hydrogen to aid in space travel. So you can use the lift of hydrogen to get a rocket high enough that you'll be able to avoid the vast majority of wind resistance that rockets usually incur when lifting from the ground. So this has been used historically, and I can make another video about that. But I can tell you that the method did see some success, but there were obviously some problems. The balloon tended to drift a long way, which made recovery of the rocket far more difficult, and there was practically no way to control the direction of the rocket when it was firing from the balloon. Both of these are still very real problems, but I think I've come up with an interesting idea that could breathe new life into Rockoons, as they're called, Rockoons. Now, there's still plenty of math that needs to be done here, and I'm not saying this will work out, but I'll lay it down in case anyone else wants to consider it. Now, as you may know, one of the main struggles when designing a rocket is trying to shove as much potential energy per unit mass into it as possible. That way you can expend that energy in exchange for gravitational potential energy when you fly up into space. And hydrogen just so happens to have one of the highest energies per mass out there, but the catch is that hydrogen has a very low density, so all of that mass is spread out over a very large volume. But that one factor that makes it a bad rocket fuel is exactly what makes hydrogen such a buoyant gas. So some of you may already be seeing where I'm going with this. I just suggest that rocket balloons may be able to use their lifting gas as fuel once they reach a height where air resistance becomes reasonable enough to justify dragging a giant sack of hydrogen. And pending some math, it may actually be a bad idea. I'm not sure. But providing it works, we will also have to consider the expansion of the balloons as they ascend into the vacuum of space. The consumption rate of the hydrogen by the rocket will have to compete with this expansion in order to avoid a rupture. Now, assuming that's all possible and the rocket is in space, there may be a neat way to re-enter in a much less violent way than we're used to. Instead of using a heat shield or anything like that, when you're in orbit, you may be able to tow a line of wire or just a coil or something, and according to Faraday's law, the motion of that conductor through the Earth's magnetic field will give you some current that'll allow you to split water into hydrogen. And now, if this is all well orchestrated, you could inflate your hydrogen balloon using some recovered potential energy, and whatever margin of inefficiency you incur, you could cover the deficit with solar. Then when you're re-entering the atmosphere, the buoyancy and drag of the balloon combined could be enough to facilitate a safe return. Now, I could be grossly underestimating the forces here, but if I'm not paralyzed by laziness, I'll eventually get to working and validating this idea. Let me know what you think. Maybe you can contribute. If you want to contribute in another way, just keep coming here for random ideas. Thank you.